So here's, I guess, sort of a more complex Boolean expression, but it turns out that it's not that hard to simplify. One of the first things that you can do when you're trying to simplify expressions like this is just see if there's any verbatim representations of the theorems that we already know. And as it turns out, in this one, we see theorem 10 in this in these parentheses here. And just as a reminder, theorem 10 is x and y ORed with x and y prime equal x. Now, of course, we don't have y in these parentheses, but we do have z prime and z. And this is kind of just, if you swap around, it's kind of the same form. So we know that this now simplifies to x. And we've got our and y or x prime. And then we wonder if there's anything else that we can do to simplify this. So we can kind of think, I guess that's kind of the hard thing with this problem is you don't know when you're done simplifying. You don't know if there's another step that you can do. And that's kind of something that just will come with practice. So here, we know that this is kind of one term, and this is another term that are ORed together. And so we know anytime that x is a 0, the output will be a 1 based off this term here. Anytime x is a 0, the output will be a 1. And then anytime that x is a 1 and y is a 0, the output will be 1. So these kind of, both of these terms operate in two different modes of x, right? This term comes into play when x is a 0, and this one comes into play when x is a 1. And this will only come into play if y is a 0. So this stipulation isn't really covered anywhere else. So this is kind of irreducible, meaning that we can't go any further. So this is our final simplified form for this expression.